In this video, we discuss learning outcome number 4. And this is basically about a data set's level of measurement. And this is important because it will allow us to determine which computations are appropriate for that data set. So there are 4 levels of measurement. They're called nominal, ordinal, interval, and ratio. I'm going to define all of those for you in a minute. And again, the reason why we care about this is that the level of measurement of a data set determines which types of calculations are appropriate for that data. Now, this learning outcome is a little bit more involved than some of the other ones. Our goals are as follows. We want to describe or define the 4 levels of measurement. So if somebody mentions an ordinal level of measurement, you should know exactly what that means. The same thing with nominal, interval, or ratio. And then we want to be able to classify data at an appropriate level. So if somebody tells you, I'm dealing with times, like a bunch of, times like appointment times, you should be able to classify that data as ordinal, nominal, interval, or ratio data. And then we want to identify the types of computations that are appropriate at each level of measurement. So that if you see that you've got data at the ordinal level, and somebody is subtracting that data, you should know whether or not that's appropriate when you're dealing with ordinal levels of measurement. So let's go through the levels. Here's the nominal level of measurement. Nominal level of measurement is characterized by data that consists of names, labels, or categories only. And this data is not cannot be ranged in some order, such as low to high. So when I think of nominal, I think of names. So an example is yes, no, or undecided. None of those ranks higher than the others. There's no natural order to that. So that's nominal data. Another example of nominal data is like types of trees, like fir trees and pine trees, and Fukian trees and all kinds of different trees. Those are not rankable when you're just talking about types of trees. I mean, some people might want to rank them, but when you're looking at the labels themselves, they're just names of different types of trees. So that is nominal level of measurement data, or data at the nominal level. At the ordinal level, we're dealing with data that can be arranged in some order, but differences between the data values either can't be determined or they're meaningless. So course grades, A, B, C, D, and F. You might be able to subtract the numbers, like you might be able to subtract a 95 and a 70, but that 25-point difference, well, I mean, that may or may not mean something. But when we're talking about course grades as far as letter grades, A, B, C, and D, and F, like C minus D doesn't really make any sense, or A minus D doesn't make any sense. So while we might be able to subtract those by calling A a 4 and D a 1 and calling the difference between them a 3, the differences truly are meaningless. Another example is the US News and World Report rankings of colleges. They'll have a college ranked at this level and another college list ranked at the next level and then the one after that. And sometimes there are ties based on their scoring system. But the differences, like if somebody is 10th versus 100, and there's like a 90, like a rank difference of 90, that rank difference of 90 really doesn't mean anything. I mean, if you looked at the 90th school versus the 180th school, is that the same difference as, or, 0 versus 90, or rank 1 versus rank 91? The differences really don't make any sense. So we can arrange those schools in some order, but subtracting the rankings doesn't make sense. So that is ordinal level of measurement. So whenever you hear ordinal, think of order. If you can put it in order, but it doesn't make sense to subtract them, then it's ordinal level. Data at the interval level of measurement can be arranged in order, and the differences between data values are meaningful, but ratios of data at this level are not meaningful. Now, the author of our textbook, Mario Triola, says that data at this level have no natural zero starting point at which none of the quantity is present. But I really don't think that that is the best way to describe this, because he goes on to say in the book that temperature is at the interval level. And if you've ever had chemistry, you know that temperature does have a natural zero. We call it absolute zero, but temperatures are considered at the interval level. So while they have a natural zero, that's not really what makes them interval level data. What makes them interval level data is this last idea that ratios of data aren't meaningful. If you look at 40 degrees versus 80 degrees, is 80 degrees twice as hot as 40 degrees? No, it really doesn't even make sense to talk about twice as hot or half as cool as 80 degrees. It just doesn't make sense. So ratios aren't meaningful, therefore temperature is interval level data, even though there is a natural zero for temperature, which is absolute zero. So interval level data, again, can be arranged in order. So it's very similar to ordinal data, but when you take differences, those differences in values are meaningful. So the difference between 60 degrees and 80 degrees is the same as the difference between 40 degrees and 60 degrees. But when we talk about like multiplying them or comparing them, like twice as hot, twice as cold, half as something else, that's sort of my, that's my test, sorry. That's my test for determining whether something's at the interval level or the next level. If you can use the word twice as, this is twice as much as that when talking about two pieces of data in that set. If twice as makes sense, then it's at the ratio level. If twice as something else doesn't make sense, then it's at the interval level. So twice as hot, twice as cool doesn't make any sense. So that's interval level data. Another example of interval level data are years. So you have the year 1000, the year 2000, the year 3000. Is the year 3000 3 times the year 1000? Well, I guess the number 3000 is 3 times the year 1000, but is it like thrice the years? I mean, I don't know. It doesn't really make sense to talk about ratios of these. When we're talking, but differences between years makes a difference. You know, you can talk about 1980 versus 2000 and then 2000 versus 2020. And those are a 20-year difference, and the 20-year difference makes sense. But when we compare ratios, when we say half as much or twice as much, talking about half as much or twice as much with years really doesn't make sense. So temperatures, times, measurements of time like years are interval level data. And ratio level, at the ratio level of measurement, we have data that can do it all. It can be arranged in order. You can find differences between these pieces of data, and the ratios are meaningful. Triola again says that there is a natural zero starting point, where zero indicates that none of the quantity is present. But again, temperature is the one example that I keep thinking of, where temperature is interval level data, even though it has a zero starting point. So I don't really use this idea when I'm thinking about ratio versus interval level of measurement. I'm really thinking about ratios. I'm thinking, does twice as much of this actually, is that meaningful? Or half as much or twice as much, is that meaningful? If it is, then it's ratio level data. If it's not meaningful, but differences are still meaningful, then interval level is what we're looking at. So one example of ratio level data is class times. If you have a class time of 50 minutes versus a class time of 100 minutes, that is twice as long. If you're taking a 2-hour class versus a 4-hour class, you're literally spending twice as much time face-to-face in class if you're taking a face-to-face class. So that is ratio level data. And you can also subtract, you know, an hour-and-a-half class and a 60-minute class. Well, there's a difference of 30 minutes. So differences are meaningful, ratios are meaningful. the length of the class time that can be arranged in a certain order. So that's ratio level, or data at the ratio level of measurement. Okay, so this is a summary. Nominal data is categories only. When I hear nominal, I think names. Ordinal data is categories with some order. Think order and ordinal. If you can put the categories in order, but subtracting them doesn't make sense, it's ordinal. Interval level of measurement is where differences make sense, but you can't use ratios. If you can't use twice as much or half as much, it's interval level data if differences already make sense. And with ratio, you've got differences that make sense, ratios make sense. And that's that data that you can add and subtract and multiply and divide. So let's look at some examples. This is example 1. Let's look at good, better, and best. What if those are our labels? What type of data is that? What level of measurement is that data at? I hope you said ordinal, because you can put good, better, and best in order, but it doesn't make sense to talk about best minus better or good minus or better minus good. We can put them in order, but subtraction doesn't really make sense. So that is ordinal data. Titles of novels. Now this is one where some people might say it's ordinal because you can order them, you can rank them, but we're not talking about a ranked list of novels. We're talking about titles. We're like, here's a novel, and here's a novel, and here's a novel. Like, well, we could put them in alphabetical order. Well, forget about the alphabet for a second and just focus on the titles themselves. Well, those are just categories, and they don't really have an order except for some order that we add to them, that we place upon them, like alphabetical order or some kind of ranking based on our preferences. So titles of novels are nominal data. They're just names, they're names of novels, and that's categories only. Number of TCC students. Let's think about it. Does it make sense to talk about having twice as many students in a class? It does. So ratio, we're talking about a ratio level of measurement. And then temperatures in classrooms. Again, we talked about the fact that differences in temperature are meaningful, but something is not twice as hot or twice as cold as something else. So that's interval level of data. We can talk about differences, but ratios don't really make sense, even though temperature does have a natural zero, which is absolute zero. Okay, so there are implications for computation with all of these, and they're built into the names. With nominal data, it's categories only. You should never compute anything. If we assign numbers to categories, you should never average those numbers. You should never add or subtract those numbers. If they represent categories, you should leave it alone and don't do anything with it except for maybe sort and figure out how many are in each category. When dealing with ordinal data, of course, you can order them, but you shouldn't add or subtract them. You shouldn't multiply or divide them. And then, of course, interval data, it's built into the definition that with interval data, there are differences. So go ahead and add and subtract those, but you really shouldn't multiply or divide them. Don't talk about twice as much or half as much when you're talking about interval data. And ratios. You can add, subtract, multiply, and divide these numbers and get out answers that actually make sense. Now, these implications for computation are related to some of your homework problems. When you're doing homework over this material, they're going to ask you, they're going to do some computation. They're going to say, what's wrong with this picture? And what you're going to have to do is figure out what level of measurement that data is at. And then based on the level of measurement, you can say, oh, well, that was ordinal data and somebody subtracted them, or we averaged nominal data in some way. So those are our 4 levels of measurement. And again, the levels of measurement are important because they tell us what we can do with that data. And that means they give us some guidelines and restrictions on what types of computation are appropriate.